diagram. Fine. So the scroll detector and the border detector classes are subclasses of decorator. See, I have taken a decorator as a main class, I mean parent class. I have a subclass, the children class, with respect to the parent class decorator as scroll decorator and a border decorator. Fine. An abstract class for visual components that decorate other visual components. So here decorator is a parent class. I can go on adding for the component of decorator. I can go on adding the different visual components, say children classes, who are those scroll decorator and a border decorator. See here, I have this here the abstract class, visual component is abstract class. The name of the abstract class I have taken is a visual component. Now what is the operation to be performed? I am going to draw. Fine. So draw is the operation to be performed. I have inherited this abstract class into two children class. What are those? I have text view at one side, other side I have decorator. Fine. So this decorator is now complete class. Why? I have the implementation. See, this is a component draw I have given here. What are the different components I am going to add now? This one. You see this, a border decorator I want to add, a scroll decorator I want to add. So I will go for the children class again. So decorator is a parent class now. I will inherit this parent class into two children class. What are those? Scroll decorator and a border decorator. So what are the operation to be performed here? I want to go for a draw and I want to go for scroll too. Fine. For with respect to border, I want to draw. Draw is the main operation to be performed, and the operation what you have added is draw border. Fine. So now, what are the return values? I am going to implement this both the case. What is it? I have draw decorator as a draw operation with draw border to be performed. So the return values with respect to border decorator is border width. Same way you can add one more for this. You can go for an implementation of scroll. So scroll position is a return value. Fine. Here decorator will create an instance to the visual component. Fine. This decorator acts as aggregator, whereas visual component acts as aggregating. Fine. So what is the instance the decorator will create to visual component? It will create an instance named as component. So what actually the component instance will do? This will give these return values, whatever you implemented, that return values are given to the visual component. So this is how you can go on adding the responsibilities to the existing class. So the visual component remains as it is. Decorator also remains as it is. These subclasses you can go on extending based on the number of operations required. This diagram, class diagram, I have taken a main class name is visual component, the abstract class name is visual component, right? The same thing here I am using the name as component when I am writing the structure. Here instead of using directly using the names text to decorator, I have the names to be used as concrete class name as concrete component and decorator here. Fine. What are the operations? Same thing. In place of scroll decorator, border decorator, I am using the name as concrete. Here these are the concrete classes where you have to add the implementation part. So I have concrete decorator A, this is with respect to scrolling. Concrete decorator B, this is with respect to which one? Border decorator. Fine. What are the operations to be done? I need to write, perform the operation. What are those? One is to draw scroll to, and the other one is to draw border. What is the implementation part has to be included in the concrete classes. So these, after the implementation you perform, the added behavior. Added behavior is nothing but what border you have finished. What is that? Border width is the return value. That is the behavior change the behavior take place. Your added state is nothing but scroll position. That is the return value. So these return values are given to the decorator class. This is the parent class which has assigned the job to this children class. The concrete decorator A performs the scrolling function, whereas concrete decorator B performs border function. So these results, the results are the return values which are sent to component. This decorator acts as an aggregator again. This component acts as aggregating. So this will create an instance of component where these return values are sent to component. Fine. So decorator is a concrete class and these are all the concrete class where you have the steps in implementation. The first step here, interface conformance. How is that interface done? How the parent class is inherited to children class? How whether the interface done is confirmed or not. So a decorator object's interface must conform to the interface of the component it decorates. So this, whatever the children class you take now, that interface must be conformed to the decorator. So what are the children class you take? Concrete decorator classes, one for scrolling and one for bordering. That interface should be conformed to the decorator, to the parent class. So omitting the abstract decorator class. There is no need to define an abstract decorator class when you only need to add one responsibility. So again, not necessary to go for another decorator. Same decorator, you can go on adding the responsibility. Fine. Keeping component classes lightweight. That means that's what they say. You will go for little number of objects, not the heavy weight, the small objects you are going adding. To ensure a conforming interface, components and decorator must descend from a component class. Fine. It's important to keep this common class lightweight. So for the same decorator class, I am going to add n number of little objects. It should focus on defining an interface, not on storing data. I am not worried about the value what I have written is stored or not. At that particular instant, I have finished doing the job. Later, I will delete also. Right? These are loosely coupled. I mean, it is visible for the clients. So the client can go on request for n number of operations. Right? So these are lightweight, means loosely coupled. So changing the skin of an object versus changing its guts. We can think of a decorator as a skin over an object that changes its behavior. Here skin means what? The decorator. Object means what? The components. What you have added, border, scroller, all that. So here the change in the skin takes place with respect to the object. Fine. Whatever you change, no, the behavior. You go on adding the responsibility, no. Based on that, the skin will change. The decorator performance will change. So an alternative is to change the object guts. So for that, we go for another pattern called strategy pattern. Strategy pattern means what actually does? It has a family of algorithms to be executed. As you go on adding the number of objects, here algorithms go on increase, right? So strategy pattern will be able to execute the list of the algorithms requested by the clients.